Hey, how's it going? It's your old pal, Mr. Cook. We're gonna do number 7 and number 8 in this one. Well, we'll see what happens. Maybe we can do the rest of them. We'll find out. Okay, number 7. So with number 7, again, you just try to like plug the numbers in and see what happens. So if I plugged in 0, I get natural log of 1 minus 0, which is natural log of 1, which is 0, plus x is 0, and then plus 1/2 of 0 squared is 0, all over 0 to the third, which is 0. So I get 0 over 0. So it looks like this is going to be one of those L'Hopital kind of situations. So, right off the bat, I know it's going to be in a determinate form. So, I just do what I need to do. Write out the limit as x goes to 0 of the top part, natural log of 1 minus x plus x plus 1/2 x squared. That's going to, become 0 overall. And then in the bottom part, the limit as x goes to 0 of x to the third is also going to be 0. So then I write it out. 0 over 0 is an indeterminate form. Oops, indeterminate. So we use L'Hopital's rule. All right, so L'Hopital's rule allows us to take the derivative, so that's what I'm going to do. Here we go. So this is equal to the limit as x goes to 0 of the derivative. So I've got chain rule here. So natural log is something. The derivative of natural log is 1 over something. So it's going to be 1 over 1 minus x. Now the chain rule, I need to multiply by the derivative of the inside, 1 minus x, which would be negative 1, plus the derivative of x, which is 1, plus the derivative of 1/2 x squared, which would be x. And then that's all over 3x to the second power. All right, now, if you were to plug in 0, you'd get 0 over 0 again, and you'd have to do L'Hopital again. So they're actually like, and you can do this. You can go through this a couple more times. You'd have to do L'Hopital 2 more times, and then you'd be able to get a limit. And I believe the limit is negative 1/3. But I'll show you how to get that in one kind of easy step. You just got to kind of know how to do the algebra for it, but it does get you a solution. So first off, let's make this thing look a little bit nicer. Let's move that negative 1 up front, up top, and then let's move that over here, plus 1 and also plus x. Okay, now, what I can do here is, let's see here. I could... All right, so what I'm going to do is multiply the top function and the bottom function by 1 minus x, okay? So the top and the bottom by 1 minus x. So the reason I'm doing that is to get rid of this like division by 1 minus x, okay? So if I do that, I would distribute all that stuff in. So this gets distributed in here. Now, what would happen with that is I would get negative 1 over 1 minus x times 1 minus x. Do you notice what happens there? The 1 minus x is like, cancel out. You just get negative 1. So that'd be negative 1 in the numerator. Now if I distribute it in over here, 1 times 1 minus x is just going to be 1 minus x. And then if I distribute it in over here, I get, x times 1 minus x. And then in the denominator, what I would get is 1 minus x times 3x squared, okay? All right, so let's see what happens with all this stuff. So first things first, I'm going to try to, work with this. So if I distribute the x in there, I get an x minus x squared, okay? And then let's try and simplify some of this some more. So I've got a negative 1 and a positive 1, so that adds to 0. And then I've got a negative x and a positive x, that adds to 0. So all I have actually in the numerator is a negative x to the second power. And that's really helpful because I've got an x to the second power in the numerator and also in the denominator. So those two could actually cancel out or divide out, whatever you want to call it. So that gives me the limit as x goes to 0. Let's cancel out those x squares, and here's what I end up with. I get negative 1 in the numerator, and then 1 minus x in the denominator, and then this little 3 that's left over. Now if I evaluate this, if I plug in 0, here's what I get. I get -1 in the top, and then 1 minus 0 is 1. 1 times 3 is 3. So -1/3 would be my limit. So that's just using a little bit of algebra to simplify. But don't worry, if you didn't catch that, that's okay. Or if you didn't think to do that, that's all right. You could actually still do L'Hopital's rule. I think it's 2 more times. And as long as your algebra checks out, you'll get the same exact limit that I just got, -1/3. Okay, so there's number 7. Now let's take a look at number 8. And if you were in my class, I usually will go through that problem using L'Hopital's rule 3 times, just to show you that you can do it. Because I realized that, like a while ago, that when you're taking a test, it's a high pressure situation, and sometimes you don't think of really simple stuff to do, like algebraic kind of tricks or simplifying. So you might do the most challenging way to go through a problem. So I think that there is something to learn from doing it a couple times. So if you want, try to do number 7 with L'Hopital's rule. You'd have to do it 3 times, but it actually works out in the end. Okay, let's take a look at number 8. So in number 8, I guess the first thing that I would try to do is plug in -1 and see what happens. So if I take 2 times -1 squared plus 3 times -1 and then -2, and then the denominator, I'd get 5 times -1 squared plus -1 and then plus 1. Let's see what I get. So in the top part, I would get 2 minus 3 minus 2. And then in the bottom part, I'd get 5 minus 1 plus 1. So that would be 2 minus 2 is 0, so -3 in the numerator. 5 minus 1 plus 1 is 5. So, hey, it looks like everything checks out. I didn't get an indeterminate form at all. So I think this is okay. That's my limit right there. So I just evaluate it. Now, here's a situation that you don't want to run into, okay? Notice that I just plug the number in and the limits are gone. Don't do this, okay? Once you plug everything in, do not write limit as x goes to -1. You know why? It's because this is saying, hey, I've still got x values. And look, I do. I have x values right here. So, I need that limit there. I need to tell you what's going to happen to x. But once I plug in -1, I don't have any x's, so there's no need for a limit. I'm just seeing what happens directly when I evaluate it at that point. So that's like why it's a little bit different, why you don't need the limit notation any longer for this. It's because you plug it in. So you just need the limit stuff until you actually plug something in, okay? All right, so there's number 8. Let's end the video here. I know it's just like a couple minutes, but that's definitely better than those 20-minute videos I made a little earlier. Okay, hope you enjoyed this one. We'll see you in the next one going over number 9 and number 10. Thanks for watching. See you then. Bye.